This episode is brought to you by GPRS. Construction professionals know that utilities and concrete reinforcements can cause big problems when you're on the job. GPRS helps you avoid them. We use ground-penetrating radar to detect rebar, conduit, and post-tension cables before you cut, core, or drill. And our concrete scans are 99.8% accurate. We guarantee it, helping you reduce hits, downtime, expenses, and keep your people safe. To keep your job site safer, visit gprsinc.com. Ever been on a job before sunrise, generators running, diesel in the air, and concrete trucks starting to stack up? And you're thinking, do we order the right mud? Is this mix going to hold up? Did I ask all the right questions in the pre-pour meeting? And if this thing goes sideways, am I going to know what to do? That's why we built Concrete Logic Academy. It's for concrete people who want to get better at the work, not theory, not recycled conference slides, stuff you can actually use on the job. Go to concreteschool.co and get free access while it's open. Again, that's concreteschool.co.
What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandit.
And welcome to another episode of the Concrete Logic Podcast. And today I have TJ Lambert with Forta. He's a sales engineering manager for them. And we're going to talk today about, what are we going to talk about today, TJ? I had it here.
Yeah.
Oh, here we go. I got it now. So as you know, as the industry is right now, everybody wants their concrete faster. But if one of the biggest schedule killers on your job isn't the pour, is not the weather or the labor shortage, but wonder if it's about what you selected as reinforcement. Maybe that kills your schedule from day one. So today we're going to talk about how your reinforcement choices affect construction speed, labor, sequencing, inspections, and overall project flow, and why this topic deserves a lot more attention than it usually gets. So TJ is going to help us out with that today. But before we get started, as always, I want to remind you how you can support the show. First off, I hadn't been doing a very good job the last a bunch of episodes on telling you or asking you how you can support the show. As far as the easiest thing for you to do is, if you enjoy the show or you get something out of the show, is share it with a colleague or a coworker. You know, it spread the word about the podcast. It's definitely got a lot of folks listening to it. And I assume if you're listening to this, you know other folks in the industry. So please share it with folks. The next way you can help me out is if you go to www.concretelogicpodcast.com. On the homepage, there's a couple ways to get a hold of me. The first way is at the top. There's a menu at the top. And at the top, there's one of the selections that says Ask Seth. If you click on that, it opens up an email form. You can fill that out. And what I'm looking for on that is topic or guest suggestions. So reach out and tell me what you want to learn about, who you want to hear on the episode, and I'll make sure I chase that down for you. And then there's another way you can get a hold of me. In the bottom right-hand corner, there's a little microphone icon on the same homepage. You click on that, you can leave me a voicemail if you prefer to do it that way. So topic or guest suggestions, that'll help me out. And then the next thing you can do is on the same homepage, there's a donate button in the upper right-hand corner. And what I'm looking for there is any donation amount. And the way you can think about it is put out the podcast, put out these episodes, and if you learn something and it's worth something to you, just send that value back. I don't know if that's $1, $5, $500, however much it is to you. You put it in there and it shoots back, supports the podcast, keeps me from putting advertisements within the podcast, because it does cost money to run a podcast, believe it or not. It's not free. And then the next way, if you're looking for like lunch and learns or professional development hours and you enjoy the topics on the show, check out concretelogicacademy.com. That will have the courses and things and some other things for you in there. So go check that out. But I'm done selling today. TJ, we're going to get right in the topic at hand. So TJ, you're with Forta. Do you want to give people a little quick background on what Forta is? So they're like, we really need to listen to TJ. He knows what he's talking about.
Yeah, no, I appreciate you having me on, Seth. And for those of you who don't know, Forta, what mainly we do is I like to say engineering, but realistically, it's we have fibers. We have micro-synthetic fibers, we have macro-synthetic fibers, and we have steel fibers. We work on all the engineering side of it, and then we have people in the field who come in and help deliver on what our engineered designs are for those fibers. Our steel fibers is called the Helix steel product, twisted steel fiber, and then our Fortifero is the bundled macro-synthetic. Those are probably our two mainstays. So yeah, we do a lot of fiber reinforced concrete, and I think this goes great with the topic about how maybe removing some of that rebar in different applications will help with the time schedule and health and safety and everything.
Yeah, that's a perfect segue into my first question. So why do reinforcement choices affect schedule more than most people realize?
Yeah, and we see this a lot when you're looking at a design, right? You see that they put down a mesh or some sort of reinforcement. And I think a lot of people feel that a slab on grade is the only place you can utilize a fiber reinforced concrete, and that's not always the case. I mean, we do everything from a slab on metal deck to pavements. We even have the ability to replace steel in certain foundational elements. So pad foundation, duct banks, different structural elements, mat slabs, and everything. Where it really hurts a lot of these jobs is not just the time it takes to actually tie the reinforcement and the labor to tie the reinforcement, but procurement as well. We're seeing shortages in procurement of bar, and you're needing to find a solution to help. I know one of the big driving forces out there is data centers right now, and they're trying to put these things up faster than we even know what to do with. So the time is critical, but more important when it comes down to what the actual reinforcement and just replacing the reinforcement is, are we being as efficient with the design that we can be for these different elements, right? A lot of times, and coming from like an engineer mindset like I have, we go in and we design something, and a lot of times that design may be, either slightly over reinforced or, the design comes out with number 4 is at 15.5, right? Well, how many times do you see them placing 15.5? So we round it up to 4 is at 12. So I think there's a lot of variation in what we do from a design and a placement and how, utilizing something like a fiber can come in and kind of clear that schedule up a lot. Meaning that the time it takes to lay bar, the safety aspect of it, right? You don't have any bar. Your inspection actually happens when the reinforcement, the Helix or the Ferro or whatever synthetic or steel fiber you're using at that time gets put into the concrete, which is usually the day of the placement. So from a time scheduling standpoint, it really increases it. And it's really hard to say in a spreadsheet how much savings you're actually going to get until you use it on a real project, right? And I think most people out there have probably used some sort of fiber on a project, but there's more than just your standard flat work. Like I said earlier, we're used in residential basement walls, wall foundations for mixed use buildings, pad foundations on big oil and gas facilities. So there's a lot of different things that will help kind of speed those schedules up and maybe make the design more efficient than it even was. Because we can get down to the nitty gritty with a fiber. You can't always do that with rebar, right? Rebar is really good at what it does. There's no question about it. But getting as efficient as possible and increasing the speed and the time and everything that's involved from that end, I think I think utilizing an alternative material like a fiber is going to be really important for the future of what we're trying to do out there.
Yeah. Let's talk about what it looks like in the field. So, can you describe most of well, people watch this on YouTube, but so they can see if you want to use your hands and stuff. But a lot of people listen to the show. Can you describe the fibers, what they look like? Let's start with that.
Yeah, I mean, there's all different types and sizes of fibers, right? I mean, for ours specifically, have the microfibers. A microsynthetic fiber is mainly for what I like to call, surface cracking, plastic shrinkage. For those of you who are familiar with it, right? It's just talking about providing enough material at the surface of the concrete so that as the concrete cures on the surface level, it's able to hold those cracks nice and tight, almost not visible to the eye if you're standing there. And then you go into like a macrosynthetic, right, which is a little bit bigger. It's longer. It's anywhere from 1.5 inches to 2 and 2.25 inches, right? So it can vary in size. A material can vary. Polypropylene. Sometimes they have different types of materials that it actually can be, and they come in either bundles or they're just flat, different shapes. And I think it's important to understand that not all the products are created equal. Right. I mean, the different fibers can do different things. And then you get on the steel side, and I think, the ours is a twisted, so it's almost like a screw style. But then there's other hooked ended products out there. There's straight steel fibers. So each one of them kind of has its place, but the performance is very different when it comes down to it. And again, I truly promote the engineering behind the products, right? The products should all have some sort of third party evaluation report to back it. Whether it's testing, ICC report, UES, IATMO evaluation report, you got to have that in the engineering to back what you're trying to do with those products out there. But the types of products that are out there, they can be different sizes, right? 1 inch long, 2 inches long, 1.5 inches, 2 and 1/4, especially on the steel and the macrosynthetic side. Even the geometry of especially a steel fiber is important, where like a rectangular cross-sectional shape of the end of a steel fiber versus a circular, the rigid in the corners of that are going to lock into the concrete better than maybe something that's circular would, right? And the idea is you want something that's going to lock into that concrete better. Stiffness within the macrosynthetics is important. You want it stiff, but not too stiff to the point where it's going to almost lock up on you. You want some flexibility so that as that macrosynthetic is going to hold and it's going to pull apart and it's going to almost like flex enough that's going to allow that concrete to move, but not enough to where it's actually going to pull apart. So there's different elements to the actual fibers themselves.
Yeah. And then I assume each type of fiber has a different application, right? So they don't all do the same thing. The reason you have different fibers is for different reasons. So you hit a little bit on the shrinkage cracking.
Yeah.
There's depending on the application, that's how you determine which fiber you want to use.
Yeah, your more structural applications are always going to come in for a steel fiber historically, especially for our steel fiber. We're one of the few, if not the only ones, that is able to do like a structural replacement for a footing. We've done wall footings and column footings for big tilt warehouses and different applications like that. But even macrosynthetics, I mean, they do a lot. They carry a lot of strength in a test that's called a ASTM 1609 beam test. They can carry a lot of what we call residual strength. So they can carry a lot of post-crack capacity, right? The load that's going across that crack. So you have your macros that perform very, very well in those tests. And some macros that perform, well, but they all have their place and types there. Your macros are going to be more your flat work, right? Great for pavements, great for interior slabs. I mean, you're still going to be the more structural based applications. And then obviously you touched on the micros being plastic shrinkage applications.
So, the big one, a good advantage of the fibers is you either reduce or even eliminate traditional rebar reinforcement is kind of one of the selling points. But let's talk about what does that look like on the supplier side as far as the concrete producer. Sorry, concrete producers.
Mm-hmm.
What additional steps or labor that they have to take on for us to use fibers?
Yeah, no, that's a good point. I mean, a lot of the concrete producers out there, we do take away the bar, right, which helps everybody on site, obviously. But then you start adding fibers to a truck or into a mix, and now that adds a little bit more labor, right? But a lot of what we do from the fiber side is try to optimize that process when you get into adding the fibers into the mix. And one of the ways we do that is with our macrosynthetic or our synthetics. We have a dissolvable bag that happens. So the minute that bag hits water, it dissolves, the fibers disperse, it's mixed into the drum, right? Post-loaded after all the concrete is already mixing in the drum itself. So usually it's a conveyor, bags, these dissolvable bags on the conveyor, goes up, falls in, bag, essentially disappears, right? And then all the fibers disperse. So we try to keep it as easy as possible for the people actually loading the fibers into the trucks. That includes, we do a range of different bag sizes as well, right? So a typical macro dosage is probably somewhere between 3 pounds per cubic yard and 7.5 pounds per cubic yard. So we really try and optimize the bags, right? 10-yard load, you got a 5-pound dosage, right? 10 5-pound bags and be on your way. Make it easy for the people who are doing this to try and all that labor and everything that we took away on the job site, we don't want to add it back. So we try to keep that process as simple as possible, keep the mixing as simple as possible. And with a lot of steel products, for us specifically, it's hard to put steel into a bag. You got a lot high carbon steel. They're not pretty pointy, right? So ripping through a bag is always a possibility. In case it's something like a brown box, right? And in the same concept, instead of just throwing a bag onto a conveyor, it's just dumping that box onto a conveyor, right? So we get it down to, if you want to be very specific, our goal is depending on dosage. And again, for the steel fiber, it's going to be between 9 and probably 30 pounds per cubic yard.
Wow.
We try to keep it somewhere, 45-pound boxes. 9 pounds would be 2 45-pound boxes on a 10-yard load. So empty those 2 boxes, shake them onto a conveyor, let it fall in, mix the drum, right? There's some rotations that have to happen. Usually you're looking for 100 to 200 rotations after the fibers hit the concrete on the inside. But, trying to keep it as simple as possible. And on those lower dosages that we use, we try to keep it, between 1 to 2 minutes per load. That's what you're trying to accomplish. On the higher ends, you're probably 4 minutes, 5 minutes, maybe is kind of what you're looking for. So you're not adding a significant amount of time and labor. You usually have, a singular person at the end, just adding in fiber. And what that saves is, I've always liked this stat because we got it from a contractor for a large fulfillment warehouse that we did back in 2018. He had number 3 bars at 16 in a 6-inch slab. And he said for tying bar, it was like every 10 to 20,000 square feet was roughly about a day of time saved. Is kind of how he equated it. And that was just always something that stuck in my mind, right? So on a 1 million square foot warehouse, if you can save a day every 20,000 square feet, or even if it's 30,000 square feet, that's a lot of time saved when you go back on it, because you're not decreasing the amount of concrete. If anything, these contractors are getting up and going farther. When I don't have bar, I can dump faster, right? I can direct discharge. I'm not having to have a pump in here or some poor person who's got to have a hook. If you've ever seen those guys with the hooks trying to pull like a mesh up or a light gauge bar up as the mud's hitting the ground there.
Yeah, if they make the effort to do it.
Or you got people, you're driving on the matted bar and you got somebody as they're backing up trying to chair it as fast as they can, right, before the concrete hits it. So direct discharging, if you can increase your pour from a 30,000 square foot pour with bar to a 40,000 square foot with fiber. Talk about, deliverables, right? Your time, it's important. And a lot of these guys have, if you don't hit your deadline, you owe me X amount of dollars per day after. So I think that's an important part that's kind of overlooked is you can go farther because instead of having to pump or telebelt or whatever the case is, I can put 5 trucks discharging at one time. You give me sometimes I've seen them up from 1 to 2 laser screeds that are working and they're really going to town just trying to put down more mud to get out of this building.
Yeah. Yeah. I was going to ask you too, by the time this episode comes out, we've released we did an episode about the EPDs.
Mm-hmm.
Is that come up as far as a comparison to traditional rebar? How does fibers, I guess, has that been a choice because of there's a global warm, a GWP that folks want to hit on a particular job? Has that come up on any of your projects yet?
Yeah, I mean, we see that a lot. So we do a lot of work in like the energy sector as well as the mission critical data centers. And I think that's a big part of where the GWPs and the carbon reduction comes into play. All of our products do have an EPD. All of our products have an LCA as well, life cycle analysis. So we actually run carbon reduction calcs for our clients who ask for it. And what you typically see is, depending on what the original design is, a single mat of number 3s versus a double mat of number 5s is a very different carbon, calculation. But you're typically anywhere from 20 to 60% carbon reduction based on the rebar to fiber conversion, right? Especially with the macro synthetic, you're talking steel to essentially a plastic, right? So the steel takes a lot more energy to actually manufacture. So the macrosynthetic is a great option for looking at something that's lower carbon than what an original design is. And then another factor about that is, where is the product coming from? Right. Our manufacturing is located, we got Michigan and we got Pennsylvania for our two manufacturing, something where maybe coming from overseas or coming from a different location, it affects how much carbon you're actually utilizing. And in the case of some of our power jobs that are federally funded, you're looking at, Buy America, that comes into it too. So all that plays a role into the actual total carbon reduction and environmental sustainability that we're providing.
I think we were talking before we hit record. The Forta was on episode 22, and one of the things we talked about back then, and I still hear it today. That was back in 2022, so over 4 years ago. The finishers having difficulty finishing slabs that have the fiber in it. What additional education do you think needs to be out there about fibers and that effort that needs to be made, or maybe it's blown out of proportion as far as finishing with fibers in the mix?
Yeah. I mean, that's always you get all ends of the spectrum, right? When, I've traveled across not just the country, but the world, watching different people finish fibers. And I think the big thing is making sure, in all finishing, and not just fibers, but making sure the conditions are good for finishing. I think that's a key part of it. But I think one of the nice things, because I talked about earlier with the synthetic, the rigid fibers versus like a more flex that has something more flex or not as rigid fiber, is the not as rigid fiber, similar to like the one we have. It allows you to work it in a little bit more. The more rigidity, right, the harder it is to work them into the concrete itself. Point about it is, our fibers are gray. The synthetic side are gray. So a lot of times it blends in very nicely with the concrete, where if it's white or a different color, it sometimes sticks out a little bit. But I think it's all about making sure you have the right conditions. It's the right mix, right? As you start to get into the higher synthetic dosages, you start need to worrying about maybe not necessarily losing water, but you need to make sure you have the optimal amount of water or paint, right? To work that higher dosage of a synthetic into the concrete. And that's all something, our engineering team, we like to do like a full mix review designs and everything to make sure that your dosage is going to finish the way you want it to, right? Because we all understand, an owner walks a slab that doesn't look good, right? And there's a lot of people very unhappy. So it's all about getting together beforehand, making sure we have the right tools out there, making sure we have the right mix design and optimal finishing. And that's for our synthetic. And then for our steel fibers, I always say that you got to have some form of vibration, and typically you see like a laser screed into a bull float. But with steel fibers, a lot of it comes into timing, meaning that if you wait a little bit longer and you start to see aggregates on the surface, you're going to see steel fibers on the surface. The steel fibers are going to move like the aggregates move. Most steel fibers are more dense than the cream or paste. Therefore, as they start working and vibrating it down and the aggregate starts to settle underneath that paste layer that we want on the surface, that's where the steel fibers or the helix will as well. If you over vibrate and you get segregation where aggregates are at the very, very bottom and more paste is at the top, you're going to get a lot of steel fibers down towards the bottom as well. So it's just about timing like you would with a normal slab. And then same thing as you start to saw cut, right? Timing, you hit a saw cut right and some of the aggregate starts to pop out on there. You're probably going to get steel fibers that pop out as well. That's the thing you don't necessarily have to worry about with synthetics because they're not as stiff as the steel fibers are. You can usually can cut right through there, but the steel fibers are high strength steel typically, meaning that you're going to saw cut right through most synthetics and not rip them up with some of the steel. If it's not a good sharp blade, skid plate is it's not a newer skid plate, it's going to start maybe ripping them up. So it's just making sure that we're on the same page and we relay all that information from the beginning.
Gotcha. Speaking of mixed design, I was going to ask you, as far as I'm trying to not piss a whole lot of people off that are listening to this show, talk about Type 1L cement. As far as it having less paste, have you seen any difficulties with Type 1L mixes? Because you're mentioning paste is kind of key to using the fibers. Has that been a challenge for the fiber folks?
I don't know if challenge is the right word. I think it's been, I think it's been a challenge for a lot of people in trying to understand exactly what the timing of 1L looks like, what type of water you're going to get, what's curing time look like. It's going to take me longer. It's going to be faster. How quickly do I need to jump on a slab? From our end, it hasn't changed too much, to be completely honest with you. I do know it does change when you start to change the timing of the finishing. That's where, we have to work with them to make sure that, hey, you still got to make sure you're hitting all your timing correctly with the fibers because of the potential issues I mentioned before, right? If you don't have enough, if you're not getting on it at a certain time and working the synthetics or working the steel fibers down, you could get more at the surface than what you typically had because of the different timing from like a 1-2 perspective and the different types of, and not as much paste that you're getting. I've seen a great example is, and I'll go into the steel fibers, is that when I started here, over 6 years ago or 6 years ago now, with the 1-2, you could wet cut within 4 or 6 hours after completing the finishing process. And you would blow right through those saw cuts. They would look clean. They would look crisp. They would look great. Now, if you do that with 1L, you start to see more of what we call raveling, whether it's aggregate raveling or raveling of the fibers itself, to the point where, they get done finishing at 2:00 on Tuesday and they're coming back Wednesday at 6 a.m. to saw cut. So when you talk about the trying to speed up the process, right? I mean, these are just things I've seen out in the field. I don't have, and I want to be clear, I don't have all this data lined up showing that it is the 1L that's happening. I'm just going from real life experience of what I've seen, 6 years ago to today. But I would think everything with the fiber, it's less about the mixing and more about the timing of everything shifts a little bit depending on where you're at. Again, there's a lot of things that affect the timing of finishing, but that would be what I've seen personally from the fiber side of it, and maybe adding in a little bit more like mid-range or something that's going to add a little bit more water to the.
Yeah, I was wondering if there was anything when you said you review mixed designs to see I assume compatibility with your fibers. If that's obviously we're all dealing with it. You don't have a lot of choice out there right now.
Yeah.
But like if it's a fly ash mix, it's got fly ash in it or slag, are those things that you can work with, or are those things you're like, we might have to change the mix design itself for the fibers to work?
Yeah, that's a really hard question because some of the owners that we deal with regularly like to see or are changing mixes for the sustainability aspect of it. But we have said, I've seen some designs that come back that are 50%, replacement. It's kind of, we definitely put out some sort of, I don't want to say warning, but just, this is going to be a very tough slab to finish, guys. With or without fibers, I think it won't be a very easy slab to finish. But you add fibers in, it's just another level of like complexity to finishing a slab. And that's the part of this where we tiptoe a fine line of making sure that we are happy and excited about what they're putting in there, and it's going to work well. And, but you also, as a fiber supplier, you got to be kind of self-aware that maybe this is a mix we don't want to get into because of like the complexities of finishing it, and just making sure that the owner's going to get what they want at the end of the day.
Okay. I think that's good for engineers out there that are considering it to hear that. So I appreciate you sharing. Is there any, if an engineer is listening, I know there's engineers listening to this. If an engineer that's listening to this show wants to consider using fiber, is there any changes in code or anything they need to take a look at that maybe they don't do normally if they're using traditional rebar reinforcement? Is there something they need to educate themselves on?
Yeah, I mean, there's a couple of different code paths that we can go down. It sounds weird, but the main fiber reinforced code that you'll see used regularly is ACI 544. That's specifically for fiber reinforced concrete. That's going to give you can go there. It's referenced in ACI 360, which is slab on ground, right? That's where we look at providing replacement for slabs. And then you have ACI 330 that allows you to use fibers, right? It's more of a plain concrete design, meaning you're utilizing the plain concrete as your essentially the modulus of rupture for your concrete, and you're providing bar for temperature shrinkage, right? Or crack control, or something that you're utilizing maybe some load transfer across saw cuts for. That's where we can come in with our products and help out from there. But there's also this pathway that we use with our steel fibers where we can actually go into, I believe it's chapter 1.10 in ACI 318, where you can use an alternative means and methods section based on having third-party approved evaluation reports to provide more structural steel. So any sort of mat slab design, foundation-based design. Now, there are limitations to what we can do. There are limitations to what that code allows, right? When you get into seismic, it's a whole different ballgame. But there is that code path that allows you to look at these different designs for fibers, everything from 544 into 360. Those are going to be more your flat work based approaches, and then 318 is going to be more of your actual structural approaches. That's usually more of the steel fiber route, where you look at actually taking out, we'll say steel that's in bending potentially. So we use all three of those pathways every single day to provide. And then if you want to throw pavements in 330 there, we use all four of them technically. Daily to come up with our designs and to give the engineer calculations that make sense, that they can back with the code, with the testing, our product testing, and then put it in their plans as saying, hey, this is a code certified way of doing, and I'm comfortable with it.
Cool. All right. If there's one thing you want everyone to remember from today's episode, what would that be?
My issue is I talk so much and then I forget what I talk about. No, I think the big thing is that, fibers have a good place and they can help with a lot of things, but it is still important to make sure that the engineering behind it and that you're coming up with the most efficient designs. Don't just accept that, taking out the bar and putting in this dosage is going to work. Get with your fiber supplier and actually work with them on coming up with a true ground up design, right? Can we take the loads? Can we take the subgrade? Can we do everything in our power to make this the most efficient way possible while still meeting those codes we mentioned and still meeting it from a calculation standpoint? Let's think outside the box a little bit here to help with all the constraints that we're seeing out there, from procurement to time to safety. And I think that's going to be the important thing moving forward is working with people and seeing what the best strategy is. Because where I feel we do the best work is when we can sit down and talk and say, what do you guys actually want here? What are you looking for? What's the owner looking for? Can we come up with something that makes more sense than what's here? Or maybe it is as simple as just hey, take out the bar, give us a dosage, we're going to call it a day. But I think having that conversation and talking about a more innovative or creative way to do it while staying within the codes, and the design is important. But that's why I like what I do, is because I get to have those conversations. I still get to use the engineering side of my brain regularly.
Yeah, that's great. Yeah, so I think that's perfect place to pause for today. If people want to learn more about what you're doing and learn about Forta, what's the best way to reach out to you, TJ?
Yeah, you can. I think my LinkedIn's going to be somewhere in the notes section here. But you can call me, you can email me. My email is thomas.lambert@helixsteel.com. Feel free to text me, call me. 734-864-6904. Happy to talk. Happy just to talk general fibers with anybody out there. So feel free to reach out. Forta's website is out there as well. So take a look at what our products do, and you can reach out through there as well.
All right. Well, I appreciate you coming on the show today. And like you said, I'll have, if you didn't catch all that contact information, check out the show notes. I'll have a link to TJ's profile for y'all. But yeah, thanks for coming on the show, TJ.
Yeah, thanks for having me, Seth. Appreciate it.
Yeah, and until next time, folks, let's keep it concrete.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit concretelogicpodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
Ring, ring, that alarm always sings. Couple hours before the sun comes up. Open up the side, put some diesel in the lights, and wait till the trucks roll up. Yeah, this ain't how most folks live their lives. Dripping in sweat, working overtime. But while they tie their ties for their 9 to 5s, we're out here changing these skylines.